Good morning. Uh, Today we are going to see an Autolisp applications. I have program for AutoCAD to create the numbering of the structure. So now you can create the structure in AutoCAD, number all the structure in AutoCAD, export it, and then you will have almost most of the work done. And the remaining thing will be to add the geometric constraints, but in this tutorial we are not going to talk about that, just only about the Autolisp routines. The structure we are going to deal with is this bridge. So it's a non-symmetric bridge with a vertical mast, backstay cable, tension cable, and vertical hangers. So the first thing to do will be, I'm not going to draw the geometry, it will be already drawn. So the first thing to do will be to open the starting geometry for the form finding. Remember that we are going to use vTcl-FormFinding software, and for this work you need to have starting geometry, that is more or less the connectivity of the nodes, and then apply all geometric constraints to be able to solve the equilibrium solution. So this geometry is already numbered, but I'm going to delete all the numbering. So deleting all the numbering. Now all the numbering is already deleted, and we are going to start to number all the geometry. So the first thing to do is to load the application, the Autolisp application, that is in form finding for vTcl form finding LSP. The first thing it does when you load the application is to open the text screen and to show up the list of commands. It has this application that is command reset, is to reset all the global variables. Num nudo is number to number node number numbering. Num elem is to number the elements, and export is to export the geometry to .ffi file format. So it's open this text window just to remember you the commands. So the first thing we are going to do is unlock all these layers, and we will start to number. So we are going to number the deck first. It is asking for, here at the bottom in the command area, give me the text height. Is we introduce the height for the text that is going to introduce as numbering. Group divider is for grouping the nodes and the elements. So it's suggesting 10,000. We are going to apply 10,000. Group number for the deck will be number 1, and start number is 0, and increment is 1. After we have this, we can start to introduce the numbering, and the numbering is at the end of each line. we have the OSNAP, the capture enabled. So we have the dex node number already, that is in group 1, starting from 0 with increment 1. Now we are going to number the cable member nodes. So nudo, give me the group number, will be number 2. Start number will be number 1, start number, and increment is 1. I'm starting from 1 just to have the same numbering for the cable and for the deck in the same order. So starting to introduce all this. Once we have this number all the nodes, we are going to start to number the elements. That is num elem, the group number 1, that is for the deck, start number 0, increment 1, and now we start to introduce the numbering for the deck. Here I had a mistake that I didn't pick the middle point of the segment, that is of this segment, but if this happens you can move the text to the middle point of the line and that will work. Now we are going to number the cable. So num elem, group number 2, starting from number 1, increment 1. So this member is number 1 of group 2. After this is done, we are going to number the vertical hangers. So num elem, group number 3, starting from number 2, increment 1. So these vertical hangers. Then group number 4 for the mast, start number 1, increment 1, is only one member. Group number 4 is the mast, and group number 5, start number 0, increment 1, it is the backstay. When we do this, we have already all the geometry number, nodes and elements, so we can export. The tolerance is to evaluate all the structure, is asking for the tolerance 0.01, that is enough. So all the elements and numbering that is in that region are considered to be in the same node, so 0.01. I'm going to override this, and now you have to pick all the entities you want to export. What is this? Sometimes the node numbering is too big. Let's see if we put in the top view, export. What is this? Export. You know, the problem is that the numbering is too big, and when it's try to capture, we are going to do a reset, export, give me the tolerance 0.1, group divider 10,000, pardon. Why is this happening? Yeah, it's in the same, it's in the middle of the mast. Export. Well, doesn't want to work. It's working for most of the numbering. There is this file. There is this exporting almost everything, but doesn't want to work for this element. And that numbering is in the middle of the no, it's in the middle. Layer, numelem, export, 10,000, yes. It works. Yes, the problem is that the numbering is too big, but what it makes the capture to the number, in this case the 4, all the edges of the number 4 is too far from the mid point, so when it makes the capture, it's not capturing any numbering. But if you make it bigger, the tolerance, then it's working. I put a big number for the text height just to be able to see it, but normally you have to use 0.2 or meter or something like that for the numbering, and then you will have no problem with this issue. The only thing you have to take care is that in the layer naming, you see that the green one is the cable, and the name of the layer is 3 arguments, let's say, with the spaces separated, and it's the name of the layer, space, the minimum value you want to have in that member, and if it is positive, it's working on tension. If it is negative, it's working on the compression. For example, the mast is negative, so here you specify the minimum force you want to have in that member, and with the sign, depending if you want it to work in under tension or under compression. If you want if you put a 0 there, it can work either under tension or compression, depending on the form finding. And then the last value, the third one, is the initial load, the initial force you want to have in that member. So for the cable is plus 1000, for the mast is minus 1000, Passarella is the deck, is also working under compression, backstay cable is working under tension, and tensores is hanger that is working under tension as well. You have to do this to the 3 arguments in the layer naming, just to be able to export these values to the input file. So once we have this exported, this is the file created automatically, and And it is not only exporting the geometry and the nodes and element numbering, it's also creating all the different blocks you need to have in the file to be able to solve it. So you can see these blocks and modify them in your favorite text editor. I'm using Notepad++. That is a good one. Here you have all the nodes numbering. You have to change the restraints of the nodes, element numbering with these arguments I told you, and then all the different geometric constraints you can apply are produced here with an explanation, so you can start to add them. So just to save time, I have this file already created, and with all the we have all the geometric constraint. That here we are using fixed node plane, and with only that geometric constraint you can solve the form-finding of this geometry. But I'm not going to explain how I have applied this. It's in the next tutorial maybe. But let's say that you have everything as a help here to be able to add this geometric constraint by hand. If we solve this geometry, we can solve it. This geometry, this file, graph screen. Here we have the input geometry, and when you start to solve it, you see how it's finding the solution. It needs a couple of more steps, and here it is the equilibrium geometry. Well, I hope you find this interesting, and see you next time. Let me see if I can